So this little video is going to be all about heart murmurs. First of all, there are 4 different types of heart murmurs. Number 1, valvular stenosis. Number 2, valvular insufficiency. This is where things regurgitate. Number 3, congenital anomalies. That's like atrial septal defects, ventricular septal defects, and patent ductus arteriosus. And then increased blood flow. And that'd be like hypertrophic cardiomyopathy. The types of murmurs can be divided into 2 categories, the systolic and the diastolic. The systolic murmurs, there are 6 main types, the aortic stenosis, pulmonary stenosis, mitral regurg, mitral valve prolapse, ventricular septal defect, and hypertrophic cardiomyopathy. And then the diastolics are divided into 4 main types, aortic regurg, pulmonic regurg, mitral stenosis, and the Austin-Flint murmur, which is basically very bad aortic regurgitation. And then you can have a 3rd category, which is the continuous type of murmurs, and that'd be PDA, or a combination of 2 different types of murmurs. And just as a refresher of where all these murmurs come from, we'll draw a heart. Here's the right atrium, left atrium, the ventricles, and then we'll add in the valves. You have the mitral valve, the tricuspid valve, the aortic and pulmonary valves. So the reason that you get some of these murmurs during systole is when the ventricles contract, you get regurgitation through the incompetent mitral valve and the incompetent tricuspid valve, causing regurgitation murmurs. And then with the pulmonary valve and the aortic valve, you get noise if they're stenotic, because as the blood flows through, it makes harsh sounds when it tries to pass through the narrowed opening. So these are the aortic stenosis and pulmonary stenosis. So in diastole, when the right and left ventricles relax, blood wants to come from the atria in. And if you have a stenotic tricuspid valve, that makes sounds. Same with the stenotic, or with mitral valve stenosis. That's a diastolic murmur. The pulmonary valve incompetence will cause pulmonary regurgitation, and aortic valve incompetence causes aortic regurgitation. So those are all the diastolic murmurs. Okay, now sort of as a summary and also as another way of breaking down these murmurs further from systolic and diastolic, you can take your systolics and divide them into mid-systolic, holosystolic, and late systolic. The mid-systolic murmurs are aortic stenosis, pulmonic stenosis, atrial septal defect, and HOCM. Holosystolic is mitral regurg, tricuspid regurg, ventricular septal defect, and late systolic is mitral valve prolapse. The diastolics, early aortic regurg, pulmonic regurgitation, and the Austin-Flint, which is basically aortic regurgitation. And then the mid to late would be mitral stenosis and tricuspid stenosis. And then other diastolic murmurs would be the PDA. Atrial septal defect is a defect in the septum between the left and right atria. So when the heart constricts, the left atrium is a little bit stronger and forces extra blood from the left atrium through the right atrium, down through the tricuspid valve, into the right ventricle, and out through the pulmonic valve. What this does is it causes a harsh systolic type murmur, and it's a lot like pulmonary stenosis murmur. So atrial septal defect and pulmonary stenosis murmur are both systolic murmurs that are heard in a similar spot when you auscultate. The next kind of unusual murmur is heard in hypertrophic obstructive cardiomyopathy. This is a systolic murmur such that as the ventricle constricts and tries to push blood through the aorta, there is a hypertrophic thickening at the root of the aorta that causes a crescendo decrescendo type murmur. So as a ventricle contracts harder and faster, the murmur gets louder and louder, and then near the end it quickly dissipates. Mitral regurgitation and tricuspid regurgitation both occur during systole, so it's a little difficult to distinguish between them. One important point is that mitral regurg does not increase with inspiration, and tricuspid regurg does. So when the heart constricts or contracts while you're taking an inspiration, the inspiration causes increased filling of the right atrium and therefore increased filling of the right ventricle. Since the right ventricle is more full, when it contracts, it can contract harder and is going to cause an increased amount of tricuspid regurgitation. So TR increases with inspiration. With pulmonary stenosis, you get the same effect. So during inspiration, you increase right atrial filling and right ventricular filling. Therefore, there is a lot more contraction and blood moving out through the stenotic pulmonary valve. So with pulmonary stenosis, the sound increases during inspiration.